Hi friends, in this video we are going to derive current ID in MOSFET. So whenever we talk about MOSFET, MOSFET is a 4-channel device. One channel is drain, source, gate and body. So whenever there is a current in drain, the same current will enter the source. This is because in MOSFET, current to the gate is 0 as it is an insulator. It won't allow any current to pass. So here, if we derive the current relation between ID and VGS, it is the current relation between IS and VGS also. Because as ID is equal to IS in MOSFET, we separately don't mention this in any case. Now as you can see in this figure, as it is an NPN, this N MOSFET, so both the source and drain are N-type materials and body is a substrate is a P-type material. Now the main point for forming the channel is VGS, gate and source voltage should be greater than VT. So whenever VGS is greater than VT, a channel is formed. Whenever the channel is formed, then there will be the flow of electrons from source to drain. Whenever there is a flow of electrons, there will be some current in the channel. So we are going to find that current from source to drain as this. Now, whenever we talk about current, I is charge per Q equal to IT, so I equal to Q by T, charge per second. So first we need to calculate the number of the charge accumulated in the channel. For this we use Q equal to CV relation. Now where this capacitance is given by this metal oxide. This metal oxide has some capacitance Cox. Okay, this Cox is capacitance per unit area. And we get the capacitance as Cox into WL, where WL is area. Okay, mark it as first equation. Then coming to voltage, we got the capacitance value, then when we require voltage. So whenever there is metal, the voltage drop across the metal is VGS, the voltage drop across the oxide is VT, threshold voltage, and then the voltage drop across the channel will be VGS minus VT. Okay, now considering here VGS minus VT minus VDS by 2. This minus VDS by 2 is given by, see, whenever we consider a point here A, B, C. At this point, the voltage VDS is 0. That means there is no drain to source voltage here. So whenever we consider the point C, at this point we have drain to source voltage. What we do is, we take the average of A and C and average of the voltages at A and C, and it will be VDS by 2. Okay, so we are going to subtract VGS minus VT, the whole voltage, and from VDS by 2. This is second equation. Now from here, Q equal to C into V, Cox into Wn, already got from first equation. This is from second equation. Try to substitute this. Now we got the equation for Q. We know that I equal to Q by T. Now I can write this as I equal to Q by L into L by T. Okay, where Q by L is one term and L by T is drift velocity. Okay, now length per time is velocity, so VD, it is denoted by VD here. Now we also know from the relation between electric field and voltage as equal to VDS by L. Here DS is drain to source voltage. Equal to V by L. V by L is a electric field equal to potential per length. Okay. Now this is the velocity relation, and between velocity and electric field relation are related by mobility of the carriers. Vd equal to mu n into E. Substitute E equal to Vds by L here. We get the sixth equation. Now Id equal to Q by L into V by D. Already we got Q by L into Vd already we got mu n Vds by L. Substitute this here. Then you get this equation. Okay. This is the equation for Id in linear region. Now we'll see how it is in the linear region. See, Id equal to mu n Cox W by L into Vgs minus Vt, Vds minus Vds square by 2. Okay. What all we did till now is for small Vds currents, small Vds voltage, for small Vds voltage. Okay, small Vds voltage. So I will neglect Vds square by 2 here. So I get Id equal to mu n Cox W by L into Vgs minus Vt into Vds. As Vt is also a constant, mu n Cox W by L is a constant, Vgs is fixed, only changing is Vds. So the graph between Id and Vds will be linear. Okay, the graph between this and this will be linear. As we all know that I equal to Vd by Rds, Vds by Rds. That is voltage current drain source, voltage current drain source by ratio of drain source. Okay. Now what happens is, initially when it is in a linear region, this is actually you can see this part is all constant and the variable is this. So this is in the form of y equal to mx, and it is a linear graph up to some extent. Now if we start increasing VDS, then what happens is